I don't think this is how gravity works.
It's the gravity from the star. It's pulling us in.
What do you mean? The gravity works exactly like that. They pull them in.
Well, okay. The shuttle is escaping the gravity of the star, and then it kind of hits a wall. It's going, and then it stops very suddenly, like it hits some kind of wall, which is very odd considering the size of the shuttle. Tiny.
Why is it odd? Maybe I don't have good intuition on this.
All right, so I made a picture.
Made a picture.
And
Very
what I
cool.
mean by tiny is the gravitational field changes extremely slowly over the distances the shuttle will travel. So
Okay,
if
wait.
we look at,
Can you slow it down? Like, what is this picture? Walk me through it.
yeah, okay. So the center yellow dot
Yep.
is the star, and the green arrows represent the gravitational field pulling any object nearby in towards the star. So
Okay,
near
so
the
it's
star,
always
go ahead.
inward, and near the star, super strong, long arrow.
Yep.
And as you get farther away, the arrows are smaller, indicating
Yep.
a weaker gravitation. Okay, I'm with you.
Exactly. So it's true. As you get closer to the star, it gets stronger. That could be in the gravity well. As you get farther away, the star's gravity is weaker. You're not pulled in
Yeah.
as much.
Yeah.
However, there's no wall here because if you
That's
look, there's
right.
I drew a little rectangle and lower to the
Here,
left
here,
of
here.
the star. Yeah, right
This
there.
right there. This little tiny box.
Right. And this little tiny box represents maybe the distance the shuttle has moved, which is actually, this is still enormous. It'd be much smaller. But it's tiny on the scale of the solar system, which means if we expand the box, like zoom in, we have an insert here, that across this box, which is just an area of space, gravitational field is pointing towards the center of the star, but it's kind of uniform the whole time.
Okay, so if you're on the ground floor in New York City and you go up to the Empire State Building, however many floors that is, you are up higher than the surface of the Earth down on the ground floor, but the difference in height is not significant. Like, it's pretty much the same gravity everywhere. Don't worry about it.
That's right. So on Earth, if you go up to the top of a skyscraper, you don't feel lighter because you're farther away from the Earth.
Like, in
Because the
principle you
difference in-
are, but like, don't worry
In
about it.
principle, you are. So here, same idea. As the shuttle moves, it's not moving through enough distance to feel differences in the gravitational field. So it's essentially a uniform field. So where's this wall that it hits?
There is no
It's
wall.
like, there is no wall. It's like has engine problems, right? Instead of, if we watch that clip again, it's like it has engine problems. Here,
Bam!
It's the gravity from the star. It's pulling us in.
making stuff up.
Yeah, gosh. Okay, I see what you're saying. In fact, it should have been even easier as they go out because the gravitational force is getting weaker. So the fact that it's like sudden stop, it's like an engine failure. But then Malloy is like, oh, it's the gravitational well. Like, no, I think you didn't do maintenance on the shuttle.
On the shuttle, yeah, like what is going on? Yeah. So the other thing is everything is so urgent. And if we go to this next picture, it's like the crisis is happening within 11 seconds. 11 seconds until gravity capture. What are these time scales? Like orbits and movements of
What do you mean?
objects in the solar system are much longer than this.
I mean, 11 seconds in terms of life and death can be a lot. So why is it a tiny?
Well, I to the left here, I put a picture of our solar system.
Hell yeah.
And if the orbit of Mercury is 88 days. So,
Okay,
if
so
you're,
here's the sun, here's Mercury's orbit. Okay, that's fast.
yeah,
88 days.
the red is Mercury's orbit, and the yellow is the sun.
Okay.
And then if you zoom in a little bit, if you go to a tenth of Mercury's orbit,
10%. Okay,
10%
10%
of
Mercury's orbit.
yeah, it's a 3-day orbit, 3 days around the sun.
Okay.
Then if you keep zooming in, if you're in an orbit, this crazy orbit skimming the sun's surface, each orbit is 85 minutes. So the fact that our timescale to emergency is 11 seconds, like how fast are we moving? Like how close to the sun are we? What is going on?
I see it. Yeah. It's like it's urgent in terms of human timescales, but in terms of like astronomical timescales, like what a scenario did you get yourself into?
I know.
You
Because if
had
you're
days to prepare for this.
days to prepare for this, because if you're at Mercury's orbit and you're falling in, it takes days.
Takes days to get in here. Then
So
you're like in
somehow
the
we're
last 11 seconds, so like, oh, it's time to do something.
Yeah, we're like right there. We're like right on the surface. We're in. It's crazy. What a scenario!
If you're
this
right
is.
on the surface, that's the time to do something. You got to do something right now.
Right, and it says 11 seconds to gravity capture. I'm not even sure what that means. That must mean like impact with the surface. I'm not even sure.
I see what you're saying, because you could be out in the asteroid belt. And yeah, heck, I mean, Pluto's gravity captured. It's inside the gravitational well of the sun.
Yeah, that's right. It's stuck.
But Pluto is not running into the sun.
It's not running on the sun. What is gravity capture? That's an orbit, isn't it?
That's an orbit. That's an orbit, right? You're captured inside the gravitational well of the star.
Yeah, that's not dangerous. That's just
It's just
an orbit.
life. It's just life, man.
So I think it must mean gravity capture here must means impact with the surface, which means this is a harrowing scenario. They're so close to the surface of this star.
I guess that means in the future this word means something different. We should adopt the future definition right now,
That's right.
which is something.
So if I trip and fall, I didn't fall. It was gravity capture.
Gravity captured. Every time I slip and fall, just get all scientific about it.
That's right. It's gravity capture.
Gravity capture.